Hello everyone, welcome to this course on REST APIs and CLIs for Exadata Cloud Service. My name is Bal Sharma and I'm part of Oracle Cloud Infrastructure team. In this module, we will discuss primarily on APIs and CLIs which are provided by Oracle for facilitating several tasks. It is highly recommended to use Oracle Cloud Infrastructure Console to perform any activities wherever possible. But there could be use cases where having knowledge of these APIs and CLIs might help. So before I proceed further, let me take a pause here so that you can go through our safe harbor statement. The objectives of this lesson is to provide you information on various APIs and CLI which are available in Exadata Cloud Service as of today. I will explain briefly about the usage of these APIs and CLIs. We will discuss on debug CLI, which is a command line option available on Exadata Cloud Service and brings several automation for end users. We will also talk about OCI CLI and see how it can be configured in the environment to manage Exadata Cloud Service systems, as well as we will also look at the use cases associated with OCI CLI. We will also go over how to use ExaCLI for getting details from Exadata storage cell, which is an important component on Exadata Cloud Service. We will also briefly cover debug API and its use cases for manual creation of databases wherever applicable. And finally, I will take you to my demo environment and show you how you can take advantage of these tools for your operational needs. Let's see what Exadata Cloud Service provides in terms of these command line options. So primarily there are 5 APIs and CLIs, starting with debug CLI, which supports a variety of lifecycle and administration operations, such as database patching, software library updates, Oracle home maintenance, PDB operations, and also dealing with TDD management, which is part of advanced security option. The other command line tool we will look at is OCI-CL, and almost all of the operations which can be performed from console, such as database system launch or DB creations, deletions, or any operation you do with your VCNs related resources, such as creating a VCN or creating a user or identity, dealing with such operations like CPU scaling, etc. They all can be performed by OCI command line. ExaCLI is used to execute a specific cell CLI commands from compute node to the Exadata storage server that are associated within your ExaCS environment. So use cases for getting a storage cell matrices as well as diagnostic information, and users don't have direct access to storage cells in Exa Cloud Service. So this is the only command ExaCLI which enables you to get those details from your storage cell. So the next option is debug API, and we'll talk through like manual database operations which debug API supports, though it is not recommended to use debug API for those tasks which can be done from OCI command line or console for database tasks such as creating a database or deleting a database. But there could be cases where you want to create a database manually just for your testing purpose. So for those use cases, we'll see debug API, how it can be used in the environment. One thing to make a note here is, like, if you create this database from a debug API command, you might not see them in the console because cloud tooling and other activities, they need to see databases there, and there could be issues. So better to use OCI command line or console for such activities. The next command we'll look at backup API, and this API supports backup lifecycle, creating configurations for a specific backup or changing a configuration for your backups, doing any kind of restore operations within ExaCS environment. They can be easily done using this API. So there could be console which might show these backup functionality going forward in the future, and then like users can decide on whether they want to use this API or like they want to use the console for performing these tasks. But at the moment, we have only option to use backup API for doing any backup related operations on ExaCS. So we'll start with debug CLI, which is basically to provide and manage all the lifecycle operation of databases. And it's a command line interface for different tools to be used within Oracle Cloud Database. And command line interface supports logging or command history as well as autocomplete operations. Few of the input which it expects is one is database name, and you must specify the database name as an additional parameter for all of the commands. So database name is the instance that you want to work with. So there are a variety of lifecycle and administration operations which are supported using Dbus CLI, such as starting and stopping a database, starting and stopping the Oracle Net Listener. You would be able to view information about your Oracle homes. If you want to move a database to another Oracle home or delete an unused Oracle home, you can perform database configuration changes. You can manage the Oracle database software images. You can do pretty much most of the operations which is basically performed on a PDB. You can perform a database recovery. You can deal with rotating the master encryption keys. So now we'll look at some of the important considerations before using this Dbus CLI tool. So updating cloud tooling on Exadata Cloud Service is an important step because cloud tooling includes the fixes for existing issues as well as new features. And it is highly recommended to upgrade the cloud tooling once any new version or release is available. And it is important before even trying a patching using Dbus CLI. When you update the cloud tooling on database deployments hosting a DataGuard configuration, you must perform the update on both the nodes. That is one which is in role of primary as well as the other database which has a role of a standby database. So before updating, you have to make sure, or you have to know what is your current version of cloud tooling. And for knowing that, you can log into one of the node. In this example, I'm logging to my first node of Exadata, and I'm issuing a command rpm-qa/grep-i dbus tools. So this is returning me the version of cloud tooling which is available at present on my XRCS node. The next task would be to look for the list of patches which are available for your environment. And for getting that information, you have to use Dbus CLI patch tools list. So it will list out all the possible new updates which are available for your environment, and you can either pick any specific patch you are interested in applying, or you can also update it to the latest patch. And the command for upgrading to latest cloud tooling, it could be Dbus CLI patch tools apply with patch ID, and you can provide latest as an argument with this command. So additionally, like if you don't want to give it latest, you can specify any patch ID which comes from the list command output. The next important thing to know here is it makes sense to have the automatic cloud tooling updates done by itself, and Dbus CLI supports automatic patch update feature. So for using that, you have to do Dbus CLI patch tools auto enable. So what this command does is, as and when there is an update on cloud tooling, it will upgrade the environment. So think of on XRCS, you have two nodes, and it is going to update it on both of the nodes. At the same time, like if you want to disable automatic cloud tooling update at any point of time, you can use Dbus CLI patch tools auto disable command, and that will basically remove the auto update configuration. So how it does is it will create a entry inside the cron tab, and that gets checked based on the scheduling, and when a new patch is available, it performs that particular maintenance task. So you have to make sure for any DataGuard setup, you are doing this Dbus CLI cloud tooling upgrade on those instances as well. And there is a MOS note about how to upgrade Dbus cloud tooling using Dbus CLI, and it's documented under 2350471.1 MOS ID. So you can take a look at it for more details. Now we will try to understand some other use cases of Dbus CLI utility. So for using it, you need to connect to a compute node which is associated with Exadata Cloud Service deployment. And commands using the db home or db image or cswlib or oryx subcommands must be run with root administrator privilege. So one of the thing you can do is, like for OPC user, you can always do a sudo for getting to root. So you can either use like sudo from OPC user, or you can basically log into root user, and from there you can execute these debug CLI commands, and these subcommands can take another options as we discussed. So for full list of commands which are supported by debug CLI, you can take a look at this reference link here. And in this example, I'm showing you how I've logged into the debug CLI console. So from my first node, I issued debug CLI, and that provides me a debug prompt. And if you will type help, it will show you a long list which is supported using this particular CLI. So this results of list could be very long, and some of the examples could be like cleandb or enable CNS, or you can do database status or database stop, data guard failover, reinstantiate. So all of these commands which are related to lifecycle management operation for a database is possible from debug CLI. So another example I'm showing here is how you can update your software library. So you will have to give debug CLI cswlib download. So what this command does is it will get the latest database images for the XRCS environment, and depending on how many database home you have and the highest level of database home. So in my example, I had 12.2.0.1 compatibility for my grid home as well as database home. So I'm getting updates for like all of the 3 homes starting with 11 to 12. So in case like you have 18C in your environment, you will also get an additional entry for 18C database, and this particular command is going to download the applicable updates for your environment. So before downloading, you might want to look into what softwares are available, and the third example here is showing exactly same. So I have issued debug CLI cswlib list, and here it is showing me I have these patches for database homes available, like April 2017, 2018 patch, Jan 2019 images are also available. Few more images I have is NC April 2018 and 19 for my database versions 12.2 and 12.1.0.2. So these are just a few examples on how to use debug CLI for update related tasks, and I hope like this gives you a view on how you are going to execute this in your environment. Now we'll look at additional use cases with debug CLI, and as I said, pretty much all of the database operation can be performed using debug CLI. You can bounce a database. You have seen like how I was able to list the applicable software updates for my database home, and then like we seen how to download it. So it can take arguments like version or software version or bundle patch information, and depending on the need you can use this command. Database change password, you can specify the database name and you'll be able to change the system password from this command line interface. You can move a database, you can start database, pretty much you can look at the status, you can stop a database, you can update the database configurations like redo size, or if you want to rename the database unique name. So it also provides you pre-check before trying out changing those configurations. So in case like if you have to take care of certain aspects, you can correct them, and then you can go ahead with applying it in your environment. It can provide you database home information. You can purge those database homes which you are not using. You can list the DB images, and you can do all of the listener related commands like starting, stopping, looking at the status of listener. You can bounce the listener. You can perform most of the tasks which are done on pluggable databases, like checking database name, or pretty much there are other commands also. So you can do all the PDB related operations with debug CLI, and you should look at the documentation, since we are adding more and more features and support to these kind of CLIs. So the documentation might change, and you will be always updated on the latest available options. Now we will take a use case of like how to update the software library so that it is going to include a non-CDB image. And why I'm showing you here is on Exadata Cloud Service, by default, when you create a database, any 12c or later, it creates a multi-tenant architecture. Means it's create a container database and pluggable databases. So many existing databases, especially e-business suite implementations, they use a non-CDB database architecture. So that could be a use case, might be applicable to your environment. And here we are going to see how we can create a non-CDB database. And the first step is to look at what patches and tools are available. So Diva CLI patch tools list, this will show you what images are available for your database environment. So this command we seen earlier also, it is listing me all the DB versions, patches and images available. And from there, you can use Diva CLI patch tool supply and patch ID with the latest. So latest is going to upgrade your cloud tooling. And once you are done with your upgrade of software library on your service, you can create the required non-CDB image version as well as bundle patch update. So you can upgrade the software library on your service with the required non-CDB image version as well as bundle patch. And the command might look like Diva CLI CSWLib download -- version, and you are specifying the version which you are interested, and then you are specifying bundle patch and Jan 2019 with -cdb no. So this argument is indicating to Diva CLI that download me the Jan 2019 patch, and that should have compatibility of non-CDB database. So I know that like Jan 2019 supports that image, so you can always use this command to get that image downloaded. And once you have this software in place, you would be able to create a non-CDB database. So we will see an example on how we can create it using Diva's API when we go further in the slides. So you can also use Diva CLI for patching operations on database, and it is for database homes as well as grid infrastructure software home. And Diva CLI simplifying the patching operation. What it does is internally it uses exadbc patch multi command, but it's just an wrapper on top of it and simplifies the patching operations. Using this CLI utility, you can list the database patches. You can provide an argument which host name or database home you want to list the patches for. You can do patch prerequisites check, and again, like several combinations are possible. You can do it with database names. You can go with instances over here. When it comes to applying a patch, Diva CLI supports that as well, and you can specify from which particular node the data SQL is going to run. Then it also provides rollback operations, which are renamed as switchback in case of Diva CLI, and you would be able to reward the applied patches from your environment using this switchback operation. So we are not going to talk more on this because I have already covered this topic under patching for XRCS topic. So you can go into that and understand more if you are interested in. The next command we will learn about Diva CLI ResDB, and it is for registering on-prem databases into cloud. So why we are doing this today? If customer brings his own copy of database into cloud, the tooling is going to fail and it will not recognize it. So Diva CLI ResDB, it provides APIs for customers to register his database so that tooling can be used for any subsequent activities like backups or like for patching. So there is no downtime required to use this utility if the database meets all the requirements. So tool provides better customer experience with the minimum downtime to migrate customer databases into cloud. So there are certain steps we have to follow here. So the command which you see here, like Diva CLI ResDB prereqs, and then you will specify the database name, and then ResDB begin. So these are the two important commands, and we will see what steps could be involved for bringing a database from on-prem environment to cloud. So these steps could be around what you can do is like create a database with the same as an on-prem database so that the cloud registries are populated. So this is one of the important aspects. Like if you are bringing a database from your on-prem to Oracle Cloud, what you can do is go to the Cloud Console and create a database with the same name. So what that will do is it will create all the required entries, all the cloud tooling related configuration, and then you can remove the database outside tooling. So don't remove it from the console. You use rman or certain commands which you normally use in database environment to drop that database. When you will remove it using rman, then you can bring the on-prem database into cloud environment through different methods. So you can use a cold backup or rman backup, or you can set up a data guard configuration and activate. Once the prerequisites completes successfully, as we see here in the command diva cli resdb prereqs with the database name, database from the on-prem must be like of the same name as cloud database that we created, which I brought some time back. Then database would be at the same patch level also. So just make sure both the database patch versions are also same. And there could be some warnings as part of testing this prereq here. And you can ignore some of the warnings like related to DB ID or domain or service names or TD wallet status. Kind of warning. So those are ignorable. If you look at the register flow, you are creating a new database from Cloud UI. Then you are removing the cloud database using rman. You are copying or set up the on-prem database to the cloud VM. You will set up the wallets and configure encryption and run the prerequisite check using diva CLI. So whatever warnings are coming, apart from the ignorable errors, you can correct them. It could be related to maybe redo log size or control files. So you correct them, and then if there are no warnings, then you can continue with the begin operation. So as part of running the prerequisites check, it creates a log file also, and you can take a look at the log file and see for the completion message that prerequisites check is completed successfully. And then only you proceed with the resdb begin command. So I have got an example here. What I'm doing is I'm running a prerequisites check for a database exadb in my case. So this database I have created manually just to use this command and show you that what needs to be done. And here it shows me prerequisites completed successfully. So might be I have gone through several iterations. It might have complained about a few of the parameters, so I corrected them. Since this database was not created from the console or through OCI's command line, it was created manually using divas API method. So assumptions is like database from on-prem must be of same name as cloud database created, as well as database should be at the same patch level, and then this tool is going to register it and all the cloud tooling is going to work. So for running the register command, you will be using diva CLI resdb begin, and then it creates a log file also, which you can look in real time what's going on behind the scene. It runs all the prerequisites check, and once that is completed, then it is running OCD, which might take time, and then it gets completed. Then you should be able to see a message that database is registered as cloud database. And for getting more detail on this command, you can look at one of the mouse note, which is migration to Exadata cloud using simple data guard approach with minimal downtime. And here you'll be able to see how resdb command is used for the manual database to get on Exadata cloud system. Now we'll switch to OCI command line. So OCI command line interface, it provides all the features access of OCI console through CLI. So this tool facilitates automation when interacting with OCI services, and OCI CLI needs to be configured with proper authentication credential to communicate with OCI service. So we have already seen in OCI related lectures on identity access management. So there are various ways you can use either auth tokens or signing keys or username and password to authenticate to your services on OCI. In this example, we are going to use the API signing key, which is needed to communicate to any cloud tenancy. We'll look at it later in the slide, how those configurations are done. First step is to install this OCI CLI. You can use either a Linux machine or Windows compute environments. So not necessarily you are going to install this tool or command line option on XRCS node. So ideally it should be separate from there, like on any other compute. It could be your monitoring infrastructure in the cloud. You can install these on these Linux or Windows machines. And when it comes to operations supported by OCI CLI, there are several operations which it supports, like to control the Exadata, IO resource manager. You can either use console or the CLI options. You can manage the database deployments, means you would be able to launch a database system, and you can control like a start, a stop databases using command line. You can scale the database, you can add another keys, you can provision it, you can manage the compute node operations and see the service level details. You can list out any networking resources you have. You can do large data transfers using OCI command line. It supports a variety of use cases which is applicable for managing XRCS. So now we'll get into the installation of OCICL. So you need to open up a Linux terminal, and you need to run the installer script. In this example, I am considering a Linux machine, but you can install it on Windows. The commands are going to be a little different, which you can look into documentation. So you need to choose the directory where you want to save the executables as well as a script of OCI. And another thing you have to make sure is the machine where you are going to install this has the internet connectivity. So once you have internet connectivity, it will start installing. So Linux OS should have internet connectivity. It will prompt you to update your path. You need to select yes. And then after selecting the path, installation will become successful, and you should see it in the message which comes from on the console. To check the OCI CLI installation, if it was successful, you can type OCI help, and it should be able to tell you the version of OCI command line which has got installed in your environment. So once CLI is downloaded and installed, the next step is to configure it for your Oracle tenancy. So now let's talk about how to configure once your installation is done. You have already validated with OCI help command that command line option was installed successfully. And once the installation is done, you need to run another command, that is OCI setup config. And you can set the defaults for config locations and need to provide several other details we will see in the example. And for finding those details which are required for completing this particular step, you will have to log into your web console and get some values. So one of such thing is like getting the OSID of the user. And for finding that one, you will have to navigate to OCI console. Then you will have to go to identity. Then under users, select the user for whom you are doing this setup and copy the value of OCID. So if you know, the OCID is basically an unique identifier for all the resources in your tenancy. So for either it's a user or it's a database or any file, everything is going to have a different identifier that is known as OCID. Then again, continuing with the same step. So once you run this OCI setup config, it is going to first ask you the location of your config file. And once you provide that location, it will ask you user OCID, and you have already obtained this particular value from OCI console as we discussed previously. Then the next thing, it is going to prompt you to give a tenancy OCID. And again, like for getting this one, you will have to log into your console, and under administration, you will have to look at tenancy details, and that will get you the OCID of that particular tenancy. Then it is again going to ask the region, and that is the region your admin has subscribed. So it could be US Aspen region or Phoenix region or Toronto region. So select the correct region and then it is going to ask for generating a new RSA key. If you don't have the keys, you can type yes, so it will generate a new one for you. And if you already have one, you can type no, and then it will prompt you to give the location of your private keys. Once you have generated the new private key, or after specifying the path of your private key, you should add the corresponding public key in the console. So this is additional step, and we will see in the example like how we are going to do it. So for uploading the public key, you will have to navigate to the user under identity and then add the public key, which we are going to see in the example slide. So once adding public key is done, the configuration will be completed and you will be able to connect with your tenancy. So it was a two-step process: downloading it and getting that installed, and then running the setup config command and provide certain inputs which are needed for you to communicate with your tenancy. So example here shows like how to get those values which are required by your setup config command. So first thing was getting the OSID of the user, and here you see like I have logged in with my user, and for that user I'm copying this value which is listed here, and that will be one of the input. Then another thing is for getting tenancy information. It will also have an OSID, and you are going to get it from the console. For API keys, you can specify the public key, and this screenshot shows like it has an option of specifying at the public keys, and this is the public key which either gets generated newly using the setup config command, or like if you have used a private key, so corresponding public key is going to be uploaded here. This example here shows all the steps we discussed so far. So OCI setup config we ran, it goes through a few of the information like OSID and tenancy OSID and regions and general configuration documentation. So these are some of the ready reference if you want more information on those terms which is asked here. And then you are specifying the location for your configuration. So I have accepted my default. I'm installing it using my OPC user, and default location within the Oracle OPC home, it is going to create a folder .oci, and inside there will be a configuration file. So this folder gets created. This is the default. You can specify your own directory wherever you want this tool to be configured. Then it asks for a user OSID, and I have provided this detail. The next one was tenancy OSID, and I provided again the tenancy OSID here and the region. So I have selected US Aspen -1. There are several regions, but depending on your you are going to change this. The next step was to either create a new RSA key pair or like use the existing one. So here I created yes, and in that case it created two files. So one is OCI API key public.pem and OCI API key.pem. So this one is basically a private key, and this one is the public key. And with that, the configuration gets complete, and it also provides you information on like how to upload it. So if you have not already uploaded your public key through the console, follow the instruction here. So instruction is nothing but you will have to take the value which is in this public key, as you can cat to this file and get the values and go to the console within the user which you want to use. Just update the public key there, and that completes the installation component. So it is shown here like copy value of public key to OCI console as shown here. You have taken the value of the public key and navigate to console under identity and then users, select the user and then API keys and add the public key. So once public key is done, configuration will complete and you will be connected to your tenancy. And that's where you will start using all of the command line tools which OCICL has to offer. So we will quickly go through some of the commands which you can perform just to give you an idea. You can always refer the documentation, but you can deal with all the IAM compartment operations, means listing all the compartments which are available in your tenancy. You can create a new compartment, you can get a specified compartment, You can update any compartment using OCICL. You can list all the available domains within compartment. You can perform activities related to users using OCICL. So here I'm listing from my tenancy that OCI IAM user list -c. I will provide the root compartment ID, and I'm limiting just to 3. So you can take a look at the documentation. There are several changes or like things gets added for syntax and usage of those, but idea here is to familiarize you to what you can use with these commands. So you can get any OCI user details. You can create a new user in your tenancy. You can delete a specific API signing keys. You can create a new Swift password for the specified user. So Swift password is nothing but auth token that is also used for various activities within the environment. So it could be related to backups. You might be generating this password. They use auth tokens. You can list the Swift password for any specified user, or you can also update the password description or create new one-time password for console user. So several things you can perform command line when it comes to identity access management. Then when it comes to the database, you can create a database, you can get a database details, you can list out a database within a compartment, you can delete it, you can also look at the system shapes by using OCI command line. You can perform pretty much all of the operations like DB node stop or start or reset or soft reset, list all the nodes in a database system. So several commands here. You can launch a database system. You can use OCI database system launch command. With this input, like generate full command JSON input, it will show you all of the options which are available for a database system launch, and then you can customize it and use that one. You can terminate a database system. You can see a database system state. These details like DB system ID, and then the argument is going to take the system ID. So these are nothing but the OSID of your database system. So again, like you will have to get these details from the console. As I said, like there are several commands which will even list the database system. It will provide you those OSID values which you might need in this particular example. So list a database system or update a database system here in terms of CPU core count means a scaling of that instance. You can list a database version. We'll again look at few more examples. So here I'm showing you how you can list the VCN. So OCI network VCN list -c and the compartment ID. So this is the OSID of the compartment, and it is showing me all of the VCNs which are created within this compartment. With the output, I can see like the CIDR block is 10.00/16. This belongs to a VCN. Then the compartment ID, I'm getting the DHCP option ID, routing table, security list, and all of that. So depending on your system or setup, you will see these values will change. You can format these outputs which comes out of the command using -- output table. I highly recommend you to look into the documentation reference for using all the possible scenarios and more details. So here we see that how we are using for XRCS operation, just continuing from before. You can perform any of the OCI web console operation that you have privilege to access, modify, delete, or create. For example, you can list all the VCNs in a particular compartment, and we've seen the example before. So OCI IAM compartment list, it lists the compartment. Then you can again, with the next command, I am able to list all the subnets within my VCN. So OCI network subnet list -c, and then I'm providing again the compartment ID and the VCN ID here, which I have already received from here, my previous command. So you can build these commands if you know what can be done. There are several activities you can perform. This example shows database list from the compartment. I'm providing the OSID of compartment ID and then database system ID OSID. and it is listing me all of the databases which are available. So in this example, it shows me VMS prod, that is the only database with all the characteristics which is listed out here. I've truncated the output because it will be a long list depending on how many databases you have. Next, we are going to look at we can create and delete databases, and for creating a database, my example here, OCIDB database, create database system ID. I provided the OC of my DB system ID, then the admin password. That these are the mandatory parameters. So for creation or deletion, there are certain mandatory parameters which you will have to provide. As I said in my previous example, you can always generate all the JSON output for if you don't know the command, like what it expects, so that will be created, which will be easier for you to specify. Here I'm giving my database name as testcdb, and I'm also specifying the PDB name as testpdb, and database version I'm instructing to create 12102. Depending on your need, you can create 18C or 12.2, but the main intention of showing this example is you don't have to go to OCI console for doing database provisioning. You can very well do it with OCI command line utility. And one of the advantage of using OCI CLI is like it will make sure all the cloud tooling is going to work once database is created. So that is different than like DBAS API use cases. There you can also create the databases, but I'm not sure like if you would be able to see that and all the cloud tooling is going to work. So you might have to do some more work. So in order to minimize that, we recommend to either use the CLI, OCI CLI, or use the console for these kind of activities. So when I provided this input, you see that database on the console, it goes under updating status, and it takes some time, and you will see the database which you are creating within the console. So you can create the database, you can delete a database by providing the database ID, and it will remove it from console. So as I said in the beginning, certain mandatory parameters, they are basically database system ID, the admin password, database name, and database version. You can specify PDB name and character set if you want to. Next example, we are going to look into how we can scale the OCPUs in XRCS. You can scale a service to OCPU count you want to use. So, on XRCS, it can go all the way from 0 to 92 in a quarter rack configuration. And think of a situation like you are using just 4 OCPU and you want to go 8 or do 92. So it's easy to control using OCI command line. So the syntax is OCI DB system update, CPU core count. You will provide the core count, and you will also need to provide the DB system ID, and that is going to be database system POSIT. So this example shows how I have done in my environment. One thing you will notice, like this host is my OEM host or monitoring host. I have not set this OCI command line on XRCS, but with that configuration, I'm able to do all of the operation. So OCI DB system update, then CPU core count to 4, DB system ID I provided. This is nothing but the OSIT, and then like it was able to basically scale it. You can see the values which are already set for your database system using get command, and again the only input is the database system ID here. So now we will move to XRCLI, and XRCLI is used to execute specific cell CLI commands, and it performs monitoring as well as management function on Exadata storage servers. So one thing here is storage cells in the XRCS environment, it is not directly accessible by customer. The only way to get the storage cell matrices as well as any diagnostic information is through XRCLI. So in order to use this utility, you need to know the cluster name, and for getting cluster name, you can log into one of the node in your XRCS environment. So log into the first node, do a sudo to grid, because OPC user can sudo to grid Oracle as well as root. Then command to get the cluster name is crsctl get cluster name. So it will tell you what is your current cluster name, and in my case it's xdb cluster 035. So once you have this cluster information available, you can next use the exacli command, and the syntax is like exacli. You need to provide the login name, and the login name is the will take argument like you have got the cluster name. So cluster name here underscore cloud user underscore cluster name. So cluster name you got from this command, and you will append it with cloud underscore user. So that will become your exacli login. Then hyphen cookie jar and hyphen c, and this value 192.168.136.4. so it is IP address of one of your storage cell. And there are several ways to get storage cell details. On even a quarter array configuration on Exa, you have 3 storage cells. They will be you can find it in cellip.ora or several other ways. You can see in documentation how to know your storage cell details. So once you have all of that, it will ask for the password, and here you have to make sure the password is nothing but the same password which you used during provisioning of a XRCS system. So you provided password for sys and system users, and that also becomes applicable for this XRCLI login. So this user will be using sys and system password. You will have to get that one, and then you are able to authenticate to a storage cell. So once you get into this, it will provide you a prompt. In my case, it shows XRCLI cloud user this is the IP address of your storage cell. And once you are there, you can perform any activities like list grid disk details, or you would be able to list the cell disk. You can list the flash cache or IORM plan. You can look at the flash log. You can look for all of your pluggable databases. You can also look at alert history or so there are several things, several commands available to be used with XRCLI. You can look into the documentation and use depending on your need. So you can list out all the cell details. It will show you like how many CPU counts or what kind of status, like whether a flash cache mode is set to write back or like it's not set to write back. So all those details you'd be able to list using these commands. So the next topic, I will move to dbus API, and as I said in very beginning that Exadata database system include these commands. These are command line tools for performing various tasks related to database. We highly recommend to use console or OCI command line for performing activities wherever you can, like database creation or deletion. You should be going to OCI console and get that done from there. But you might see that like you have certain use cases where you don't want to go to console, and you want to create a database just manually, and maybe for test and dev you don't care about cloud tooling for those databases. Then definitely you can use this tool. Thing you have to keep in mind, like you might not see the database you create using dbus API in the console, but that might change. Also, if we are building some functionality going forward so that it will be available in the console also, but at present we recommend to use OCI CLI or console for these activities. I will show you an example of non-CDB database, and cloud tooling means on OCI console we have no way to create a non-CDB database at present. So this would be one of the use case for using dbus API. This tool expects a JSON input file, and again, like it is located under var opt oracle dbus API, and you will be running dbus API -i and JSON input file, and all the calls are going to be synchronous except when the status is requested, which is going to be synchronous. So all calls are by default asynchronous. So command parameters could be object, operations, actions, and params. So it could have nested JSON object for operation specific parameters like database name or node list or out file or flags. The object could be target object for current DBAS API process to be triggered, like for databases it will be DB, and there could be operations to be performed like snapshots, a clone, or iBackup. Actions could be whether begin or end or delete. So we'll go with that and see steps for creating a database. To get us started, we will create a directory called db input, a simple input file. You can give it any name. I prefer to give my input.json, and a simple output file called createdb.out. So you need to SSH to a compute node in the Exadata database system with OPC user and sudo to root user, and create a directory which is going to hold basically these files for this manual activities. So I changed directory to db input. I created the input file in the directory, and we'll see an example. We'll create a database configured to store backup in an existing bucket in the object storage. So parameter description, you can always look into the documentation what it supports. You need to run the utility and specify the input file, and when you run this, you will be getting an output, and there will be ID inside that. So you will have to take a note of the ID. Create a JSON file to check the database creation status, and note the action of status, replace the ID and the DB name with values from the previous step you get. Then you need to again run the utility with the status file as an input, and then check the utility output. And this you are going to continue unless the operation is succeeded or failed. So we'll look at one of the example. As I said, we'll create a non-CDB database using non-CDB software image. So this activity is already part of the MOS node for non-CDB, creating non-CDB database using Oracle Database 12c on the Exadata Cloud Service under 2528257.1. So this talks in much detail about how to create a non-CDB database. But on a high level, the steps are again same. You will create a directory, go to the directory, you will create a createdb.json file that is going to be the input. And few parameters you will notice here is I have given cdb equals to no, and bundle patch I'm going to use Jan 2019, and the rest of the options like db name, edition or version, admin passwords. So there are few important parameters or mandatory parameters you can say, but there are few parameters which are not mandatory, like character set you can even leave. It will by default it creates L16 UTF-8. Then node list I'm not passing anything, means it is not a mandatory parameter. From wherever you will run it, the database will be created on that particular node. Additional parameters which I am specifying is backup destination as OSS, means I'm not interested in disk backup, just do a cloud backup here. And if I have given that option, it asks for container. So container details, that is the Swift object storage bucket information. So this bucket I might have created earlier in my storage cloud on OCI. And then you will have to provide the cloud storage user as well as the storage password. So this username and password is nothing but the auth tokens for this user, and this is one way of communicating to OCI storage bucket, and it is basically one of the method within identity access management which is used for authenticating to OCI services. In last, I am specifying output file, and that is createdb.out file. So when you run this step 1, it will create the output file. So here I'm doing a cat of that output file which got created earlier, and important information in this is the ID parameters. So ID value is 43. I'm going to track this value in my next command, and it also provides you the log location. It says that object database status is starting and the output file is here, and also a corresponding log location. So now, since you have already ran this command for creating the database, you are going to create another JSON file and update the ID information which you have received earlier. So ID 43 we seen in previous command, I have updated it here. The database name is non-CDB ball in my case, and this input of my create dba status.json. So this file I'm going to execute several times and look at when the creation is succeeded. So I ran the same command again, like dbus api -i create dba status.json. So it is giving information that status is in progress, and id is 43 and operation is create db. So you will have to repeat this step regularly until the response indicates that operation succeeded or failed. You can always monitor the log file which you already identified in createdb.out to follow the progress. So for example, tail of this command is going to show you what's going on behind the scene. Now we'll move to the next API, or the last API we discussed in the beginning, and that's backup API. And backup setup is done via this backup tool, which is part of basically dbus tool RPM. And you can always check the version of which dbus tool is installed using rpm-qa grep dbus. And you have to also make sure you are on recent versions of cloud tooling. And we have seen examples about how to use dbus CLI commands to update or keep your cloud tooling current. With the recent version of this RPM, backup entries for database for which the backup is configured will be configured on all nodes in etc cron tab, and backup channels are load balanced across the available nodes via db name. There are two backup entries for each database, one for level 0 and level 1, and one for archive logs as well. And backup can be configured with one of the following backup destination. Means it provides you like whether both cloud storage and local storage, only cloud storage, and none. So there are much detail about this topic under this link, and for more information you can also look at my module on backup and recovery on XRCS. So that talks in much detail about how you can start with the backup configuration, or like you can do restore operation where configuration files are written. So for more details, I would encourage you to either see this link or the session on XRCS backup and recovery. So with this, we will move to the demo section, and in the demo, we will go through several APIs and CLIs we have seen, and their practical uses. And with that, let me get into the demo. So let's get into the demo. To start this demo, I have logged into one of my compute node through OPC user. So from here, I will navigate to root user. Because most of the operations we are going to perform are administrative in nature, means I'm going to show you the way you will be updating your cloud tooling. And again, for doing that, you need to be root as the user. So first try to find out what cloud tooling version you have on your XRCS environment. So for doing that one, you can always use the rpm grep command, and you have to look for dbus tools _exa. So here, if you notice, the dbus tool version on my platform is 19.04.09. So this is the version which is available, and we need to definitely know what is the latest version available here on XRCS. So for finding the latest version, you can either like go with the xrdbc patch sm command. They would be able to list it out. So let me use that command. And here I'm again going back to my xrdbc patch sm folder, and that command is going to list out the available patch for this XRCS environment. So if you notice here, it is saying that my current version of cloud tooling is 18.2.3.1 19.04.09, which is pretty latest, like not very old, but it has also found another patch which is available for the environment, and that is 190415. So definitely this is the latest patch available uh, for my environment on XRCS. So I will show you how to update this one. So before doing that, like updating is simple. We can go ahead and like give a command using xrdbc patch to update this. So this command is going to is just like this: give the tool inst and rpm version equals to latest, and you can remove the latest keyword and you can specify the exact patch id which is available here uh, on the screen, and it would be able to update that one. But before going to that, I will show you, you can also use additionally diva cli to do this activity. So for diva cli, command is going to be diva cli patch tools list. And again, diva CLI, it is going to use the XRDBC patch internally, but it will come up with checking on all the nodes that what is my current tool version, and then we would be able to apply that tool. So another thing you might have noticed that it is going to check these tools on all of the nodes in my XRCS environment. So this is a matter of choice, like you can use any tool. If you are going with the first one uh, using xrdbc patch, you will have to do this activity, update activity separately on all the nodes in the cluster. Otherwise, like if you go ahead with the dbus tool, you can specify like patch the system, and it will take care of updating those tools at both the cluster nodes. So here again, like as expected, it has found latest patch set version, which is the latest, and the uh, tool also provides you how to apply that patch in your environment, and it has come up with like diva cli patch tools apply patch id, or like you can use the latest keyword. So by using this one, I would be able to update the dbus tools which is needed for any activities, like either you are doing patching or upgrade operations, or you want to use different apis and clis. So it is a better idea to update it. So since like we have the command available, I will use this approach and try to update my cloud tooling from here. So this might take some time. We'll wait for a minute and see like if it comes out. But this is what it is going to do. Like it is looking for the version which is already there, and it found the latest version, and it is going to take an action and apply the latest patch set in my environment. So since this tool might take a minute or two, so meanwhile I'll bring another terminal and try to show you if we can run a few other API related commands here. I will log into my Exadata node. And in this example, we are going to do dbus API, and by using that dbus API, we will try to create a non-container database. Just to give you a feel on, like, process is going to be same whether it's a container database or non-container database, but I will be creating a non-container because that is the latest feature we added on XRCS environment. So I will do the preparation stuff for using this dbus API here, and for doing, I will navigate to my directory. So first let me go to root user. So one thing, like OPC user can do sudo to any user, and I had a mistake in the syntax, that's why it prompted for the password. So I have done sudo to root, and I will navigate to the directory where I am going to create the input files for dbus API. I have already created a directory over here, and I also have few files which I am going to use for my uh, database creation using DBAS API. So the first thing for creating this database, I'm going to use this createdb non-cdb.json file, which I have created for just for demo purpose. So let me show you the content of that. So here I have specified the object as database. The action is going to be a start and operation is createdb, and different parameters I have provided here. CDB is going to be no for a non-CDB database. I'm going to use the bundle path Jan 2019, which you will see like the method to download this to your software library and using dbus CLI command. But I have already downloaded it, so I'm going to use that for creating this database. I have given this database name as training. The version is E_EP. Version is 12102. The admin passwords which I'm going to use for database creation, the character sets, backup destinations, and here backup destination is saying that I want to have the database backup on Oracle Object Storage Container. Then I have cloud storage container with the URI, and that is nothing but the object storage with a bucket already created. So I have a bucket which you see here is available on my in my tenancy. So I will just verify it quickly that like is the bucket name is correct, or then like cloud storage user, it has to be the user which has the access to object storage and the auth token for your user. Then at the end, like I'm specifying the output file from this command, and this file is going to be under the same directory with name createdb underscore non-cdb.out. So this was the first step of creating this input file. You will have to make sure that there are no syntactical errors, so this colon and the key value pairs are correctly specified in this, and then we can go ahead and like run this command. So for doing that, I'm going to execute var opt oracle dbus API and dbus API inside, and with the argument as createdb non-cdb.json. So this is going to invoke it, the script, the JSON file which I have already created, and it will give me a command output which is specified within this JSON file. So what I need to do is like I will be looking at this createdb non-cdb.out here. So let me cat this file and see what is the content within it. So if you notice here, this is it says first thing is like for security please remove your input file because they are no more needed now. And another reason is like the input file had the credentials for your object storage and sensitive information in it. So it is a good practice to remove that one. The object is db status, it is showing as a starting, and output file is the same which we have specified in the JSON file earlier, and it has given a process ID. This ID is 50 here. So this is going to be used for further tracking the output of my dbus API create database operation. And the operation is createdb, and there is additional log file which is available here which can be tracked, and this should also show you what is going on behind the scene. So it does several checks, and then like this will be progressing, like it will the values are changing, and we can again, like since we have already received the process ID here which is 50 in my case, so I'm going to keep this one in the file which will be used for status tracking. So I will create db status.json in the same directory, and I believe it should be already there. So let me take a look at if I have already created. So I have created a create db status.json file, and let me show you the content of that. So this is the second step. So first step, we created the JSON file for database creation. We ran it, and then we got the process ID from the out file, and based on that, we are creating this create db status.json file. And in this one, I have already specified the object is db, action is status is what we want to monitor now. Operation is create db, and only thing I have to change is the ID value, which is going to be 50 in my case. And database name is training. So output file, again, it is going to be same, create db non-cdb.out, and that is the only change. So I will save this, and then I will execute another command to see the command output. So here, if you notice, I'm just passing this create db status.json, which we have just now created. And then again, we will have to look into the output file. We will cat this file, and here if you see, now the message has changed. It is showing that it's in running OCD phase, and object is database, status is in progress, and there are no error messages here. Out file is home oracle db input create db non-cdb.out, and now we have got an additional process ID, which is PID. So this is basically the OS level process ID, which has invoked internally, and it shows operation as create db. So this particular input is going to change, so we will have to monitor this one several times, and at the end, you should see the status as it's already created. So let me check if the P1 process associated with this database instance create training has come up or not. So right now it has not come, so it might take some more time and before it get executed. But once this progresses, you would be able to see in that one there will be a corresponding P1 process here, and that would be able to show you that database has got created. So let me check if my previous API output is done or not. So here it has updated, so it says that it was executing the command patch tool apply, patch ID latest, current tool version, and patch ID to apply was the latest, updated the device tool RPM to the latest one 19415. So these updates are done. So current tool version is on node 2 is showing up as this one, and the node 1 has not yet come, so it might be applying that also. So here in order to track the progress, this command has to be run several times, and you would be able to see that there are corresponding log entries are getting generated, as well as there are P1 processes and other database processes started. So another way to test is definitely the log file which we saw earlier with the process ID 50. So that will give you a fair idea on if there are progress or not. So here we see that it is still progressing, which might take time. So we will get into the other topic we wanted to cover as part of demo, and that is going to be dbus CLI. Uh, Later we can again come back and check the status of the database on this node. So in order to use Diva CLI, you have to enter Diva CLI on the command prompt, and then it provides you Divas as your CLI, and it also shows you the version of the database CLI utility, and in my case it is showing as 182310. So that is the version which you also see from the Divas tool RPM, right? So it's 182310. So once you are in Divas prompt, you can use several commands which are used for managing the database lifecycle. So one of the thing could be just database status, and as you know, like this CLI expects hyphen DB name as the parameter. So provide a database here and see how it gives you the status of that. So basically it is going to provide how many instances I have for my database and where exactly that is running. So it says instance BMS prod 1 is running on node XD prod N53 machine, the first node, and there is another instance which is running across my second node, and their corresponding Oracle home it is showing in the command. And it also tells you basic details like it is 12C extreme performance version of 121020. So this was just a simple command to see how we can manage the status. You can stop the database, you can start the database, you can deal with the listeners. So think of like I want to know about DB home, for example. So DB home info, then if you will not give any argument, it will show you all of the database forms. Otherwise, you can always just specify for which database you want to know this particular information. So this is what it says: enter a home name or just press enter if you want details of all the homes. So I press enter here. And it should be able to provide all the database homes which I have on my XRCS environment. So here it is. So it says the home first home is Aura home 103.12.102 with a DB patch version. So this is important, a database bundle patch version. This also helps you know which image or database version you have in your environment. The home location it shows, as well as like it will give you the patch level of that one, and what databases are installed. So this second one which I see here is showing that database installed as nothing. So definitely like it will be the one which is just getting installed, and that is the non-CDBA script like we ran using our Divas API command. So database is not yet entered in the Aura tab, so that's why it is showing it blank as of now, because it's still in progress. For all other databases, it is showing me the home. Like I have a BMS prod which is installed under DB Home 2. I have XRDB installed in DB Home 4. So all the details related to database home, it was able to show me. The another thing like you can check on like patch tools list you have already seen. So we will run some other commands. This could be CSW live list. So this is the software library on the system, right? So as I said, Exadata cloud service provides you updates in two ways. So one is through images, the other one is through regular patches as per the MOS note. Like every time, like every 3 months, like we provide you different patches available for the platform. So this command CSW live list is listing you out what patches or bundle patches are available for the environment. and this is starting with April 2017 till Jan 2019, and this is across all the database versions like 18c 11.204, and few are specific till 12.201, right? So another thing, if you notice here, is like list of available non-CDB bundle patch, and here we have April 2018 for DB version 12.201 and 12.102 version, and also Jan 2019 for DB version 12.201 and 12.102. So since like I don't have a 18c grid install, or that was during provisioning, I just selected 12c as my compatibility, so it is not showing me anything for 18c database version. But these are the ones which are available for me to create in terms of non-CDB. But for creating any normal database, multi-tenant database, you can pick any one of these. So ideally you would be interested in the latest one for your specific database version. So if you want to basically download one of these, so the command is going to be simple. You will just issue the cswlib download, and then you need to specify the version and the bundle patch tag. So command will, I don't have to provide this debug CLI, I have just copied. So this is going to be the syntax. You specify the bundle patch with the tag which is available here, and it is --cdb no will make sure that like that software gets downloaded. So since I already have this bundle patch downloaded in my software library, it is going to show you the message that it's already there. So idea is like debug CLI can be used for several operations, whether it's patch management or database operations dealing with database homes. So you can use this one for getting that database operations done. So now what I will do, I will move to another API which we discussed, basically CLI, Exacli, and show you how to do before I move to the OCI command line interface. So let me go out of it. And if you remember, for using Exadata CLI interface, you need to know what is your cluster name, and cluster name you can always find from your grid infrastructure software. So let me go to grid user first, and then show you how to get that. I'm into grid user now, and now I can issue a command like crsctl command, and it came up with the current cluster name is xdp cluster -035. So this is my cluster name which I am going to use with my Exacli command line. So for accessing Exacli, we can log in from OPC user or Oracle user. So I will go out of this grid home. I'm going to my Oracle user, and then so in order to use Exacli, you have already got the cluster name, and the syntax is Exacli -login name. Then the user is constructing using the grid cluster name, and that is like cloud_user will is the prefix, and then we'll add the cluster name in it, and then --cookie jar, and then -c followed with the storage cell IP address. So you can specify any storage cell IP address, and basically within an Exadata environment, depending on the configuration and shape, you can have multiple storage cells. So that can be found in cellip.ora as well as in the host file. You'll be able to find the storage cell detail. So pick one of that, and you can enter. It will ask the password for your Exacli, and the password in this case is going to be the same password which we have used while provisioning the initial starter database configuration. So that was the admin password for session system, and the same password you have to provide here. So I have specified the user password, and then it asks me that do you want to accept and store the certificate. I'm going to store that one, and after accepting, you are in the Exadata prompt. So now we can use any command like list grid disk detail, for example. So it has listed all the grid disk which is available in my Exadata environment. So basically any command which can be used with cell CLI can be done. Only thing is like it is a read only. You cannot change several parameters we normally can be done with the cell CLI command. You can track the status of your flash cache, and it says that like this is normal. You can also list your IORM plan if you have already enabled. So it says the IORM plan is active for my environment. You can use maybe a list flash log, and it should be telling you like if the status is normal or not. You can there are several commands which can be executed using Exadata. We have already discussed in the concept before, so you can try with various operation and see like how they help with the information needed from the environment. So here we seen that Exadata is used for getting mostly the storage cell related details, and with that one I will move to my another example where I wanted to show you OCICL. So let me go out of this, and I will log into another machine where I have already configured the OCICL. I believe this is my, yeah, this is one of my compute node which is running out of OCI, and I configured the OCI command line utility on this. So I'm not going to show you how it can be installed. That could be a lengthy process. It might take time. So I will straight away assuming that you have OCICL already installed, and I will show you the usage of that. So OCI help is going to show you if you are able to execute this command, it means OCI command line is already set. And another thing you can check here is I'm in the directory home OPC, and since I provided OCI installation directory as the same, so here I can navigate to OCI directory, and there are several files under this. So one is the configuration file, then I have the PEM files which I need to I might have provided into the OCI console during configuration. So this configuration file will have information about how you are going to connect with the Oracle Cloud Infrastructure, and you can add multiple environments. So think of like you have multiple tenancy, you would be able to access that one. So that can be achieved easily through this config, and let me show you. So I have two profiles here. One is my default profile, and the other one is profile 2, and both are dealing with two different user IDs. Basically, if you notice, the OCDs are different in both the cases, and they belongs to different tenancy. So the profile will have information on the user, the fingerprint information, the key file, that is nothing but the public key PEM format, and then the tenancy information and the region information. So this list can be longer depending on how many environment you are dealing with, but by default commands will be executed whatever is listed under default profile. So you don't have to specify, but if you want to access the another profile which is not the default one, you can specify the profile name while executing the OCI commands. So since like my OCI binaries are already installed, I have got my tenancy or compartment details. So few commands could be like OCI network VCN list -c the compartment ID OSID. So this is my Exadata compartment, and you know how to get the OSID from the console. So I will be able to list out all the VCN which I have created for my deployment. And this is what you see from here. It is showing me the VCN underscore BL, which is part of my tenancy. So this is one of the way like I'm able to get the VCN information. It shows me what is my CIDR block here, the compartment ID. I'm using default DSCP options here, my route table OSID, my security list related details. So pretty much all the details. I have some more VCNs for demo purpose. It is listing out all of them. So I have so now let's take a look at like how we will deal with the database systems, since we want to see how it works for Exadata. So another example here, I want to list the databases within my compartment ID, and I have provided the compartment ID here and the database system ID. So any Exadata system is going to have a database system ID that will be nothing but a OSID. So that as well as the compartment ID. So it should be able to list all the databases in this one. So you see here I have a database bal test which is in my tenancy on the Exadata. Then other properties associated with that database is shown, like whether it's OLTP or what is the database unique name and all of that. Then like I have another database which is BMS PDB. It is part of like BMS prod. It's a container database here. So you see that detail. I have few more no, so it shows like me the two databases which I already have in my tenancy. So if you want to create a database using OCI-DB, that can be also done, and commands are really simple. You can specify OCI-DB database create followed with DB system ID, which we know like it's the OSID of the Exadata cloud system. You have to specify the admin password, give any strong password, then database name you have to specify. If you want it a multi-tenant, you can specify the PDB name here and the database version. So this example is going to create a database. So again, database creation, it is not just a PDB creation. It is a full-fledged database. Home will be created, a new home to have this database, since we are not supporting shared homes as of now. So it will be a time-consuming process, but that's why I'm not going to execute this here. I will show you another activity which you can perform. So many times you have a need of like updating the CPU core count for your, if you want to basically scale on XRCS environment, scale up or down. So the syntax are like OCI-DB system update, and then you need to specify the CPU core count here, and you have to also provide the database system ID. So if I make it to 4, right now I believe like I have set it to 4, 2, and I want to move it to 4. So this will show you that all the details which it is going to do. So this is a quarter rack 2.92 configuration. I have a sparse disk group and all. Somewhere it will show you how many I already have, and so I have CPU core count as 2 initially, and that is going to make it 4. So this operation will take a minute, and then you should be seeing that in console also. You can verify that the CPU count has increased, and database will be in updating status. Though you would be able to connect your application, all the activities will be done as normal. It is just about enabling more CPU on the environment. So with this, I'm going to summarize this session. What we have seen in this particular module is what are different options on REST API which are available for Exadata Cloud Service Operation. We discussed about DBAS API as well as DBAS CLI, and also looked at few of the operations which are supported by them. We got an understanding on how to configure and install OCI CLI, and some of the basic operations which can be done. So we seen it through example, and we also discussed about XRCLI component, and seen some of the use cases of that one. So I hope you find this video useful, and for more details you can always go to our cloud portal, and I will hope to see you in my next video on XRCS topic. Thank you so much and have a good day.